Okay. I appreciate so much that one student remind me, Professor, record a lecture. Okay, we compute it one by one separately. 6i, 9i, 4i, and 3i. And your multiplication, 6 times 9 times 4 times 3, I did in my calculator, of course, is 648 I to the 4 power. Because we have 1, 2, 3, and 4 power. And what is I to the 4 power? Well, I to the 4 power, I can interpret it like a I squared times I squared. Porque 2 plus 2 es 4, ¿no? Y I squared I know que es negative 1, entonces negative 1 times negative 1 is positive 1. So I to the 4 power is positive 1. Therefore, my final answer in this problem is 648 is real. Because I to the 4 power is 1. 1 multiplied by any number is this number. It is real. So it's important to understand the power of I, because sometimes happen que es real and sometimes happen que es imaginary. I want to explain now in detail. So far, everyone follow me?
I have a question for the fourth example.
Go ahead, go ahead.
Our final answer would be 56i cubed.
No. Because we have, look, miss, 1, 2, 3, and 4i. You see?
No, for the fourth example.
Ah, sorry.
Sorry.
Yeah, cube.
Okay, thank you.
But cube, I prove que cube is negative I. Do you understand this or no?
Yeah, so would we write it as 56i cubed or negative 56i?
Beautiful, excellent. My beautiful final answer is minus 56i. Sorry, I forgot to say that.
Okay, thank you, Professor.
Now this is the moment that we are ready to understand more clear any power of I. So I call this topic power of I. So far, we see I, que es I, or either way, square root negative 1. I squared and negative 1, I cubed was negative I, I to the 4 is 1. Imaginary, real. What happened with the I to the 5th, 6, 7, 8, and I want to generalize the formula to find any power of I to the 200, 314, any power. What is the formula of this? Let me try to using my intuition and after generalize the formula. 9, 10, 11, and 12. Okay, I to the 5th power. And my mind, I can interpret it like I to the 4 power times I to the 1. Because 4 plus 1 is 5, no? Y I know that I to the 4 power is 1, therefore it's I. It's no coincidence that this result is equal to this. So you try to continue, we continue cyclical, negative 1, negative I, positive 1, positive I, negative 1, negative I, and positive 1. Bam, 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 bam. And we continue 4 by 4 following this sequence.
Excuse me, Professor. Can you go over that little part again, please?
What part?
With the
last column.
Yeah. Mm-hmm.
The last column. Okay. Oh, you understand that I to the 5th power is I?
Yes, sir.
Okay, yes. Do you want to continue 6, 7, 8?
Yes.
Good question. So I to the 6 power, maybe I can break it down like I to the 4 power and I to the second, because 4 plus 2 is 6, right? I to the 4 is 1. 1 is invisible multiplier. I to the second is negative 1. Do you see that? Boom. So one good clue to determine any power of I is try to find, for example, this one, 10. I to the 10. I to the 10. I try to find a multiple of 4 close to 10, but multiple of 4, what means multiple of 4? 4, 8, 12, the next is 16, no? 20, and so on. Pero close down 10, que es obvio que es 8. So you take I to the 8 power times I to the 7. 8 plus 2 is 10. But any multiple of 4, any exact multiple of 4 is always 1. Entonces, I squared is negative 1. Do you see that?
Yes, sir.
Ajá. Entonces, ya we are ready to create the formula. What is the formula to find any power of I? Well, the shortcut, the procedure, the best way, the fast way is you take the exponent. Suppose one example. Example 1 of that part. I to the 5th power. When you take 15, I to the 15, sorry. You take 15, you divide it, pero no calculator, sino you divide it by hand, divide it by 4. It's obvious que 3, because 3 times 4 is 12, and subtraction is 3. Entonces now, let me try to interpretation this division. We have 2 3, it's a coincidence, this 3 and this 3. These 3 represent the column. Wow. These 3 represent the column. What is a column? The column is, this is the column 0, the original. This is the column 1. This is the column 2. Y I suppose que the column 3 is the next. Que es I to the 13, que I suppose que es I to the 12, que I suppose que es negative 1, I to the 14, sorry. 14. I to the 15, que es exactly I'm looking for, es negative I, y I to the 16, que es 1 again. Entonces now, these 3 indicate the column, But I don't care the column, I care the row. And what row belong? The row. This is the row 0. This is the row 1. This is the row 1, sorry. Row 2, row 3. And this is row 4. So these 3 give me the row. And the row is 3, que es in the column 3 in the position 3. Que es I. Okay, this is equivalent to say negative I. Well, actually it's I to the cubic, que this 3 is this 3, but this is negative I. And this is the final answer. I did using the shortcut, I did also using the table, but the problem is the table, because you have I to the 506, so it's too long using the table. And so the shortcut is better. You divide by 4, take the remainder, you reduce the remainder to the column 0, and you take the value. So the only thing you need to memorize is this column. Let's do it. I bring 1, 2, 3, 4. For example, suppose, example 2, compute I to the 18. Well, what should I do? You take 18 divided by 4. Okay, obviously it's 4, because 4 times 4 is 16. 5 too much, because 20. subtraction is 2. So I take the remainder, I square, y I know que I square is negative 1. Boom, final answer. Good. Example 3, I to the 20. You take 20 divided by 4, f5 is 20, no remainder, 0. Entonces es equivalent to say I to the 0. Y you need to know que any number or expression raised to the 0 power is equal positive 1. That is the reason que any exact multiple of 4 is always 1. It's another view to understand que when there is exact multiple of 4 is 1. Okay. One more que I did, but I want to reinforce it. I to the example 4. I to the 9. You divide 9 divided by 4. Es obvio que es 2, because 2 times 4 is 8. Remainder 1, entonces I to the 1 power. Pero you know, 1 power is invisible, it's just I. Clear, guys?
Yes.
Yes.
You're strong in the power of I?
Yeah.
Excellent. Divide by 4, take the remainder, memorize the first column, and end the story. Can you give me the second to write it? Can you give me what? Activate the microphone. Okay, I cannot read too fast the chat. What do you say? You say something.
Exponent.
Yeah, replace the remainder for exponent. Let's do one more. Suppose I to the 23. Example 5. I to the 23. You take 23 and divide it by 4. By 5 is 20, by 6 is 24. It's too much. Entonces 5. 5 times 4, 20, remaining 3. Therefore, this is equivalent to say I cube. Y I know very well que I cube, look at that, is negative. Don't leave it like that because it's incomplete. The solution no is negative. Good? Now you understand? Yes or no?
Yes.
Yes.
Excellent.
Yes.
Okay, now I go back to the complex number. What is complex number, Professor? Well, a complex number is a combination. It's a combination real and imaginary together. For example of the complex number. Noise. I detecting immediately who make a noise. You put in mute. Okay, no problem. Well, example of the complex number. Suppose this is the complex number, 4 plus 3i. This is the combination. Look, this 4 represent the real part. This is the name, real part, and 3i represent the imaginary part. And together, it's a complex number. We have, for example, the classical real number, for example, 4 or 5, in which the imaginary part is 0. We have the classical imaginary, pure imaginary, it's a pure real. We have the pure imaginary, in which the real part is 0. Suppose 3i. When you write 3i, it's because you suppose que the real part is 0. Or negative 5i. I suppose que this. But we have combination. We have the both together. Okay, we have real part and imaginary part, and this new number is called a complex, right? And we study different operations using a complex number. The first operation that we study is a conjugate. Conjugate. It's super easy to understand. Conjugate. I hear noise. I hear noise. I want to... Angelo, no? Okay. 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 What is conjugate? Conjugate is suppose, and the notation that we are using for conjugate is suppose the same complex number 4 plus 3i. But you put the hat here to represent conjugate. This hat represents conjugate. As easy, you copy exactly the same, but you change the sign only for the imaginary part. The conjugate by definition is the same complex number, but the imaginary part opposite sign to the original. Okay? Now let's doing operation, arithmetic operation, addition, subtraction, multiplication, and division. But addition first, it's easy. Addition is, you have, for example, 4 plus 3i, I like this number, plus 2 minus I. We have two complex numbers. This is the first complex number. This is the second complex number. You have put together using addition, arithmetic operation. One of the things, you remove the parentheses, 4 plus 3i, plus 2 minus I. And we combine like term. Real, real, imaginary, imaginary. 4 plus 2 is 6. 3i minus 1i is 2i. Boom, final answer. Addition, easy. Subtraction, also easy. Subtraction is also easy. Suppose, again, 4 plus 3i, pero subtraction now, minus 2 minus I. Same procedure, you remove the parentheses. The first is 4 plus 3i, but you need, you interpret subtraction like a -1 from the subtrahend part, and you change the sign as -2 plus I. So in my mind, it's like a one invisible -1 can multiply here, apply distributive property, multiply -1 times 2 is -2, and -1 times -I is plus the I. And we combine like that now. 4 minus 2 is 2, and 3i plus 1i is 4i. Boom, final answer. End the story. Subtraction, super easy. The only difference of subtraction is a subtraction, you have minuend, you have subtrahend, and you change the sign of the subtrahend after you adding. Multiplication. Multiplication is interesting. I want to explain two cases. Multiplication. Multiplication is, suppose that I multiply again 4 plus 3i times 2 minus I. The same number. That doesn't matter. I select this because I like. Let's say the interpretation of this is like a binomial, because the complex number contains two parts, real and imaginary. So you FOIL, you multiply using FOIL, the classical mnemonic device that we use in multiplication to binomial. Okay, FOIL, first, outer, inner, and last. It's doing 4 times 2, 8. 4 times -8 is -4i. 3i times 2, 6i positive. And 3i times minus I is minus 3i squared. Okay? But I know que I squared, I know que es real y es negative 1. I know que I squared is negative 1. Therefore, mentally, you replace, because remember the last step is combine, is minus 3 times negative 1 is positive 3, ¿no? Ajá, entonces now ready to combine. Real, 11. Imaginary, minus 4 plus 6, 12. Positive. Boom. Final answer. Any question? Do you follow me? Complicated or easy?
Yes, sir.
Okay.
Straightforward.
Yeah.
Okay, straightforward. Now, I want to explain one particular example, very, very interesting, because frequently we are using this, que es the multiplication, any complex number, special multiplication. Que I have no idea que es special, but I want to discover que es special. Is when you multiply any complex number times its conjugate. Okay, remember the conjugate is the same number, but the imaginary part is completely opposite sign. No? Bueno, I have no idea. Let me try to do by FOIL again. A surprise. You multiply 4 times 4 is 16. You multiply 4 times minus 3i is minus 12i. You multiply 3i times 4 is positive 12i. And multiplication this and this is minus 3 times 3 is 9i squared. I know very well that you never leave it like that because I know. Okay, I squared is negative 1, so you must replace for negative 1. That's 16 minus 12i plus 12i plus 9, no? Because negative of another negative together become positive, but I discovered important thing. Wow, this is cancel out. Wow, disappear. It's gone. The imaginary part. The answer is real. And it's 16 plus 9 is 25. Wow, amazing. So I discovered shortcut in this special case. And the shortcut is I don't care. Well, you multiply any complex number times its conjugate, and the answer I guarantee with you 100%. Okay, the answer is real. The I part always disappear. Now, the shortcut to do in 1 second is you multiply the first and the first, 4 times 4, 16. And you multiply 3 times 3. I don't care the I don't care the sign. 3 times 3 is 9. And put together is 25. Okay, so you don't memorize this, no problema. This is shortcut that I discovered now. However, if you don't memorize, you apply FOIL and you get the same result. Okay? Let's practice a little bit this special case because it's important. Suppose you multiply 2 minus I times 2 plus I. I prefer doing by the shortcut. No? You multiply 2 times 2 is 4, no? Where come from this 4? 2 times 2. And what about this coefficient and this coefficient? Is 1, no? Okay, 1 times 1 is 1. It always plus. Always plus. That is magic. What is the reason it's plus? Because happen that situation. I square negative 1 and together. The answer is 5. Do you see or no?
Yes, yes.
Help me with this multiplication. 1 minus 3i and 1 plus 3i. Come on, do it quickly in 1 second.
It's 10.
Super! It's 10. It's 10. Why? Because 1 times 1 is 1. Always plus 3 times 3 is 9. It's 10. End the story. Everyone follow me? Special multiplication. Special is,
Yes, sir.
let me summarize. Special is when you multiply any complex number times its conjugate. Okay. One more. 3 plus 2i times 3 minus 2i. What's the answer to this? You detected. Wow. Wait. It's special. How do you know? Because it's complex number and its conjugate. Now to say suppose two things. Number one, the answer is real. The imaginary part is gone. Secondly, is the result is a multiplication. First, last. I don't care the I don't care the sign. What is the answer?
13.
13. Very well. Guys, everyone follow me. This is important to understand now
Yes, sir.
division. Let me try to explain division. Now division. Okay, now we're dividing two complex numbers. Suppose you divide 4 plus 3i divided by 2 minus i. Wow. Okay, this is my original problem. But I multiply my original problem by another expression. Okay, call it a smart one. And you know, one is invisible multiplier, but this smart one contains the conjugate of the complex number in the denominator, no numerator, denominator, que es 2 plus I, and 2 plus I. And you know, any number divided by itself is 1. That's the reason it's a smart one. But this is smart because this simplifies the thing. Fantastic. Let me show you. We are doing the multiplication. Top, bottom. Of course, we are doing bottom first because it's the special multiplication. It's 2 minus I times 2 plus I. I did before Fi. Yes or no? 2 times 2, 4. 1 times 1 is 1. And 4 plus 1 is 5. Yes or no? But in the top, no shortcut. Why not? Because they are no family. They are completely different. No conjugate. It's completely crazy. And you apply foil. Foil in the top. And the bottom, no. Special. Okay, so 4 times 2 is 8. 4 times I is 4i. 3 times 2 is 6i. And 3 times I is plus 3i squared. So far, it's okay?
Yes.
Now, immediately, I replace I squared for -1. Some students, when you have habit, don't jump one step. Okay, you never write I squared because I know it's -1. Some students say, no, I don't care this. I put negative here, it's much better. Yes or no? No. Students say, no, professor, no. Step by step. Okay, no. Okay, dice Farah dice Farad say, okay, no estoy diciendo, no, too much, too fast. Let's do it step by step. Entonces now A plus 4i plus 6i minus 3, because I know this fact. Okay, I square negative. Replacing. Okay, ready to combine. Lighter. 8 minus 3 is 5. And 4i and 6i is 10. Divided by 5. But this 5 is a real number you can split like that. 5 over 5 plus 10i over 5. If 5 divided by 5 is 1. And 10 divided by 5 is 2. And the final beautiful answer is 1 plus 2. In the story. Division. Do you see this or not? Okay, conclusion. Always happy to divide any complex number. You multiply this division is given in the problem by a smart one. How? You form the smart one using the conjugate of the complex number in the denominator. And you apply a special product in the bottom and FOIL in the top. And the rest is algebra. I know in any multiplication always happen that we have a square. In square you replace by -1. And the rest is, okay, it's important that this answer is correct, but it's not elegant. You leave it like that, you can, maybe in my test, but in Alex, no. Alex picky with the notation. Alex accept any complex number you write real part plus I imaginary part. Okay, no divided by something. No. Okay, let's do another example. This is, go ahead.
Why was it 2 plus I over 2 plus I?
Say again.
Like where it says the smart one.
The smart one I formed by the conjugate of the complex number in the denominator. So I have my original problem is this. Immediately see. Wow, look at that. Denominator is a complex number. And what is the conjugate of this?
2 plus I.
Exactly.
Okay.
Entonces 2 plus I copy top and bottom. Right? Let's do another. 10 over 1 plus 3. It's example 1 of the division, and this is example 2 of the division. Wow, but this is weird, professor. You are dividing a real number que es 10 divided by a complex number que es 1 plus 3i. Well, it's the same idea, no? What should I do? I am confused. I don't understand very well. What should I do? No, it's the same. You create the smart one.
By the conjugate.
Conjugate. And where is the conjugate? And where is the
denominator?
And what is the conjugate? Help me.
1 minus 3i.
Super. You are the best. You create the smart one using the conjugate of the complex number in the denominator. And when you multiply first, you multiply bottom. What is the answer? Bottom. 1 plus 3i times 1 minus 3i. What is the answer? I suppose que es special, no?
It's 10.
It's 10. I did before. It's 10. And now you multiply, but in this case, no FOIL. No FOIL because it's distributed, because it's monomial binomial. And you multiply 10 times 1 and 10 times 3i. So 10 minus 30i. Leave it like that. No, hello. Split this common denominator, 10 over 10 minus 30i divided by 10. Es obvio que es 1 minus 3i. Boom. Final answer.
I'm sorry, can I ask a question?
Go ahead.
So the bottom, the conjugated part, along with the bottom of the original, the 1 plus 3i times the 1 take away 3i. How did you get 10?
Okay, I repeat again for you. 1 plus 3i times 1 minus 3i. Suppose I don't know, I don't remember the shortcut can explain here. I call it special. No problem, miss. You apply FOIL, FOIL again. You multiply 1 times 1. 1 times minus 3i. Minus 3i. 3i times 1 plus 3i. And 3i times is minus 9i squared, correct? This is cancelled. Yeah, I know that I squared is negative 1. Therefore, this is 1 plus 9. This guy is negative 1 and negative 1 and another negative we have in the front. A positive, the answer is 10. Beautiful?
Okay, I get it. Thank you.
Either way, so you will be able to remember the special shortcut. No, it's okay. You are doing it in 1 second. So you don't remember, no problem. You are doing by FOIL, and the only thing is the time you spend maybe 5 seconds. 1 second, 5 seconds. Okay. One more example. Example 3. Example 3 is 8 plus 4i divided by 6 minus 9i. Help me, guys. What should I do?
Wait, can I see example 2?
Pero, okay. Suppose I don't remember example 2. What should I do? What should I do? What should I do? You
By the conjugate
multiply
of
the
the
conjugate.
number of the denominator.
Okay, by the way, what is the conjugate of this complex number in the denominator?
6 plus
6
9.
plus 9i.
Es bueno. You create the smart one with the conjugate of the complex number in the denominator. Cool. Entonces, when you apply a special multiplication here, this and this together, is 6 times 6, que es 36, plus 9 times 9, que es 81. I don't care this negative. I don't care this high. This is shortcut. I am doing in 1 second. And you are in this guy, que es 170. The top, no. They are not shortcut. You apply FOIL. And you multiply 8 times 6, 48. 8 times 9i is 72i. And you multiply 4i times 6 is 24i. And you multiply 4i times 9i, que es plus 36i squared. And the smart students immediately don't waste the time with the stupid y square and erase this. You put negative here because you know it's equivalent. Now ready to combine later. 48 real, 36 real. Together subtraction is 12. 72 imaginary. 24 imaginary is 96. And leave like that, you can. But much better, more elegant is separate. 12 divided by 117 plus 96 over 117i. And fortunate or unfortunate, I don't know, we can reduce in lowest term this, and we can reduce in lowest term this. Okay, the answer is 4 over 39. You can divide by 3, no? I suppose top and bottom. And here, likewise, divided by 3 is 39 over 32. And this is more elegant finance. So this manipulation is obvious that we should do. So you multiply for a special shortcut, split the common denominator, get 117, and 2 pieces, because remember the standard notation of the complex number is always one number, maybe fraction, maybe decimal, maybe whole number, but it's a real part plus another number. This is the standard, no? No, never like that. Using common denominator. No, you split this common denominator here and here. And reduce is possible or not? Everyone follow me?
Yes, but
Yes, sir.
do you think I can see the ending of example 2? Like,
Let me see. The example 2 is the final answer 1 minus 3. Let me make it soon.
okay. Perfect.
That 1 meter.
Thank you.
Oy, oy, oy. That's a answer for the number 1, the answer for number 2, and the answer for number 3 is this. Okay. So far, any question? No? You copy? I can erase the board?
Yes.
Cool. Okay, I want to complicate a little bit, not too much, using negative exponent of I. So we come back again to the power of I with negative exponent. And you say, well, professor, what is the reason that we don't study before this? Because sometimes happen when the negative exponent you need to divide. And we need to cover division first to understand power of I with the negative exponent. For example, I to the negative 9. Exponent is negative. What means negative exponent in algebra? Somebody remember that? Or no?
Wouldn't it be 1 over I to the 9?
Exactly. Reciprocal. Very well. She said, what your name is?
Gladys.
Gladys. I need to recognize the good students. Is reciprocal. This is equivalent to say 1 over I to the 9. Okay, negative exponent means reciprocal. I to the negative 9. Cool. Now, I to the 9 is easy for me and for you doing that because 9 divided by 4 is 2, 8, remainder 1. This is equivalent to say 1 over 8. And leave it like that? No. Why no? Because I need to express the answer in standard. What means standard? Real part plus imaginary part I. So now we are from one problem of the division in which you divide 1 gets a real divided by I gets a pure imaginary. So what should I do? Division. What is the procedure for the division? Okay, you know very well. How we are doing division? Huh?
You divide by 4, use it as a take the remainder and use it as exponent.
End the story. I stop here, but I stuck. I don't understand how we continue. Because now the next computation is divide 1 divided by I. So I realize it's division. But how you divide? Remember the conjugate, no? And the smart one, no? Do you remember or no? Yes or no? Ooh.
Yes.
Yes. And what is the conjugate of I? Well, I is 0 plus 1i. Yes or no? I is pure imaginary. That means I have no real part and one unit I. It's equivalent. No? And the conjugate of this is 0 minus 1i. So opposite sign and the imaginary part. Actually, it's negative I. Do you see or not?
Yeah.
Excellent. A. Microphone off. So I discovered can you create the smart one using negative I. Where come from negative I was the conjugate of positive I. Now multiplication. 1 times negative I and negative I. Positive I times negative I is minus I squared. Yes or no?
Yes.
And who is I squared?
Yes.
Negative.
Negative 1. Very well. Entonces we have minus I divided by minus 1, no? Double negative become positive. If positive is invisible. The answer is negative. Do you see or no?
Yes.
Yes.
Yes. Let's practice using negative exponent. 2 more examples. I to the 13. Negative 13. Example 2.
Wait, I didn't get that first one.
Pero more specific, mister. What should I do?
I didn't finish writing it.
How?
Like
that?
no, example 1.
Example 1. What happened with example 1? Come on, I don't understand very well your point. Help me. How you face this problem? Negative point. Help me, I need help. I am lost.
Do you do the reciprocal?
Exactly. How do you know?
1 over I to the 13.
My question was, how do you know? So how do you know I need to find the reciprocal? What is the clue?
The exponent is negative.
Super. The exponent is negative. Now I focus in the 13 power divided by 4. The 3, 12, remain the 1 again. Uy. So it's 1 over I. It's the same. It's the same. I did before, no? Multiply by conjugate again, negative I over 1. I prove in one moment that this and this together is I times negative I. Sorry. I times negative I is negative I squared. The I squared is negative 1, and negative 1 is positive 1. The answer is negative. Wow. But it's always the same. No, always. It's a coincidence. Let me see another example. I to the negative 11. Who help me to compute that? Come on. Negative 11. What should I do?
You write 1 over I to the 11.
After that.
Then you'll divide 11 by 4.
Good. Okay, when you divide by 4 is 2, no? Because 3 is too much, no? It's 8, remaining 3, no? Entonces, 1 over I cubed, no? Yes or no?
Yes.
Yes.
I leave it. I finish?
No.
No, why no? Because I know
because
I3
is negative I.
Beautiful. It's a 1 over negative I. I leave it like that. I finish. I gotta go. No. Why no? Because of the division. I have to finish the division. Division what? 1 divided by negative I. And remember the algorithm of the division is the conjugate. What is the conjugate negative I?
Positive I.
Excellent. I like to hear this. Positive I. So say 1 times positive I, and I prove, I don't want to prove again that this is 1. Yes or no? The answer is positive I. Boom. Boom. Any question? Do you understand very well the procedure when you have negative exponent?
Yes.
Yes.
Cool, cool. I can erase the board or no?
Yes.
Guys, I am doing too fast or I am doing well?
I think it's good. It's a little fast sometimes, but it like towards the end, I think it wraps up well and I can understand it.
Don't hesitate to press
Yeah,
the
that
brake.
part is-
Don't
that's
hesitate
pretty
to
good.
press. Professor, slow down. Because I always press the accelerator pedal. Yeah, I don't know. I emotional. Do you? Divided by 4. Yeah. Do you understand what is the reason in the power of I you divide by 4, no? Because this is a sequence que es cyclical. And this is repeated 4 by 4. That is a reason que always you divided by 4, right? Now I want to do another operation, power, pero no de I, power of any complex number. Of course, second power, because third power, fourth power is too long, but it's okay. Suppose 2 plus 3i is squared. What should I do? Well, this is equivalent to say 2 plus 3i times itself. Yes or no? And you 4.
Yes.
And you 4. 2 times 2, 4. 2 times 3i, 6i. 3i times 2 is 6i again. And this together is 9i squared. Now remember, the smart student never doing this. Erase this and put it here, right? Now ready. 4 minus 9 is negative 5. Plus 6 plus 6, 12. End the story. Good. One more. You let me know, guys, if I'm doing well or not. I want to put example 1. Example 2 is a little bit weird. Because using irrational number. Entonces yo sé, bueno, profesor, what is the reason que using this weird number, no? Radical 2 over 2 plus I radical 2 over 2 square. Wow, weird, huh? But it's the same. It's the same to say radical 2 over 2 plus I radical 2 over 2 times radical 2 over 2 plus I radical 2 over 2. And you foil. Radical 2 over 2 times radical 2 over 2. I want to do here. And the rest is the same value, but include I or no. So radical 2 over 2 times radical 2 over 2 is radical 2 times radical 2 is radical 4. And radical 4 is 2. And 2 times 2 is 4. When you reduce the lowest term is 1/2. Yes or no?
Yes.
So the first is 1/2. The outer is exactly the same. It's 1/2 again, because it's the same number, but I, because include this I. This and this is the same. This and this. And this and that, again, is 1/2, pero it's I squared. Yes or no? But, you know, the students never write like that. Erase the 2, you put negative here. Now ready to combine later. First, I erase the 2, I erase the I. So you replace I squared for negative 1. Positive 1 real and negative 1 real is cancelled out. And 1/2 plus 1/2 is 1. The answer, unbelievable, is I. Wow. Surprising. Let's practice. I bring several examples of the complex number. Let's do it. Look, and you help me. Suppose que the problem say if C is equal 3 minus 4i and W is equal a plus 3i, then compute column C plus C hat, number 1, number 2, W minus W hat, number 3, C times C hat, number 4, C minus W hat. Wow. Do you remember the hat is conjugate, right? So basically, in the first one, C is 3 minus 4i, plus the conjugate of this is 3 plus 4i. Yes or no? This guy is this. This guy is this. Wow, look at that, what happened? The imaginary part is canceled. 3 plus 3, 6. Real. W is a plus 3i minus W hat. W hat is a minus 3i. Now subtraction. A plus 3i, remove the parentheses, is minus 8 plus 3i. Oh, the real part is cancelled. This is 6i. Do you follow me?
Yes.
Number 3 I did before is 3 minus 4i times 3 plus 4i, que is the conjugate. Now this is this, and this is this. See, I realized, wow, this is a special multiplication, and the professor explained a shortcut. Yeah, I know que multiply first, last. I don't care the sign. I don't care the I. 3 times 3 is 9. 4 times 4 is 16. The answer is 25. Gets real. And all will happen when you multiply one complex number times its conjugate. Now let's do it. But let's do it in the number 4 step by step, because you compute C minus W first. You compute C minus W first. Who is C? C is 3 minus 4i minus W. Who is W? A plus 3i. Now it's a typical subtraction problem. 3 minus 4i minus a minus 3i. This sign change completely. This sign inside the parentheses. Now we have negative 5. And we have here negative 7i, no? Because negative 4 and negative 3 is negative 7. And I feel no, because I need to compute the conjugate of these new complex numbers. That this hat can involve both is minus 5 minus 7i hat conjugate. And remember, definition of the conjugate is you change the sign, but only of the imaginary part. the real part stay the same, and you change the sign of the imaginary part. Final answer. You follow me?
Yes.
Cool. One more example.
Professor, what is that little line called again? The one on top?
Conjugate. This is conjugate repetition. When you see this line, that's mean conjugate. And what means that? Conjugate means, suppose you have 2 plus 3i, conjugate is 2 minus 3i. So you change the sign of the imaginary part, and the real part stays the same. Cool?
Yes.
Yeah.
Cool. Guys, this is too long class. It's 2 hours. The reason is because this is the okay. And rate by Professor Dagon, I have different comment of this class, and some people are doing no good comment, bad comment. The majority, of course, is good. Say this is not for the baby. You have to work too. There are a lot of homework, too hard. Okay, but what is the advantage? If you are good students, you take this class, you are taking 2 classes in one. Okay? And always you can with my help. I am your friend, anytime. Okay, the last example I propose you is bracket, parenthesis, 4 plus 2i, minus, parenthesis, 6 minus 4i, close the bracket, division by, parenthesis, 2 plus 3i. What should I do, guys? According to the order of operations, what should I do? Remember, according to the order of operations, when you have fractions, we can perform the operation in the numerator and the operation in the denominator completely independent. So you consider in your mind like a 2 problem. And finally, of course, you divide. So I focus it in that part. For example, temporary, I ignore or forget that part. That part is not important now. And that's a typical subtraction. So now you copy. 4 plus 2i, remove parentheses, minus 6 plus 4i. Because this minus affects everything inside this. Okay, cool. And the denominator, 2 plus 3i. The thing I did was remove the parentheses. Well, to say we have real, minus 2. Imaginary, 6. Okay, now division. What should I do? Help me.
Multiply by 2 minus 3i over 2 minus 3i.
Excellent. It's exactly I need to hear. Okay, remember special and foil. Que actually special es foil, pero en shortcut. That's what is the answer in the denominator. 2 plus 3i times 2 minus 3i. Es 2 times 2, 3 times es
13.
13. Very well. Everyone understand where I come from? 13? Or no?
Yes.
Honestly, yes.
Yes.
Now at the bottom, 2 times 2 get 4. And 3 times 3 get 9. And always plus. Unbelievable, but it's true. No hay, no negative. Disappear. Now 4 is negative 4 is positive 6i is 12i and is minus 18i squared. But remember, the good student never write I squared because you know you immediately replace by -1 and double negative become positive. Cool?
Yes.
Okay, now we combine real, real, imaginary, imaginary. 18 minus 4 is 14. And 12 plus 6 is 18 over 13. And leave it like that? No, never. You separate, because the standard format for the complex number is real part and imaginary part. In this case, we cannot do anything in the simplification or reduce. No, no, no. But leave it like that. It's okay. I understand very well. No problem. Any question? How do you feel? Strong? Strong in arithmetic of the complex number?
Yeah, I feel good.
Excellent. Let's move on in the time that we have to study in details the quadratic. Yes, Farad. Farad, ¿no? Es Farad. Farad, you are female or male? Farad? Farad. Farad is your first name or last name?
I am a woman.
A woman. Okay. Okay. Bueno, entonces now, the next topic, super important, super important. We start today and we end in the last day. It's a quadratic equation. Quadratic equation. Okay. Quadratic equation is equation que, for example, you write in standard form like that. Ax squared plus bx plus c equals 0. So don't expect que always in any example we are doing, we have in this elegant form. You need to rewrite, organize in this. And who is A, B, and C? In general, A, B, and C are real number, no restriction, maybe fraction, maybe decimal, maybe irrational. However, the only restriction is A is non-zero. Because si A is zero, si A is missing, then entonces this equation is no quadratic. It's linear. So the important, guys, in this equation is that part. Maybe we study a specific example in which B is 0 or C is 0, que es la que es especial. Cases. But in general, A never is 0. This is illegal. Because C is 0, we are talking about another thing, no quadratic equation. Okay, entonces now, suppose a special in which B is 0. And si you detecting que B is 0, entonces now our equation is super easy solving using square root method or square root approach. What is that? Let me explain it. Suppose this x squared minus 4 equals 0. My question is quadratic equation, yes or no? Of course, yes, professor. Because A is 1, the coefficients in front of the x squared, B is 0 missing, and C is negative 4. Entonces es especial. And what should I do? Well, the fantastic way to do in 1 second is you moving or you manipulate similar to the quadratic, to the linear equation, sorry. So you move forward to the other side. You apply square root both sides. And the square root is fantastic because the square root cancel out. So the second power and the square root undo each other. Is x equal, and the square root 4 is 2. But the super important moment is you put plus and minus because we have two solutions. So normally 99% of the time, the quadratic equation includes two solutions. There are some particular examples that have one solution, but the majority is two solutions. And the two solutions in this case is plus and minus. This is the square root method. And don't forget, please, when you apply square root method, in the last moment, when you apply the square root of the number that we have in the right-hand side, you don't forget plus and minus. The solution set is two solutions, 2 and minus 2. Or minus 2 and 2. Remember, the order is totally irrelevant. I don't care anymore. That's what example 1. Example 2. Everyone follow me? Yes or no?
Yes, sir.
I'm following.
Okay, excellent. Suppose this. Okay, similar, but the only thing I changed was the sign, get paused. But what I do is similar. You isolate the x squared. You move 9 to the right-hand side like a minus. Apply square root both sides. This is x. Fantastic. And square root negative 9. Oh, I studied before que es 3i. Because I know very well que negative inside the square root is not real, it's imaginary, pero plus and minus. Then the solution set is 3i and minus 3i. Or either way, guys, the order is not important. Minus 3i and positive 3i. It's not important because it's a set. And the set is important, the order. It's not important. It's completely independent, the order. O sea, the set you can interpret like a team. María, José, or José, María. The order is not important. It's the same thing. It's the same set. Another example, a little bit more complicated. Suppose we have x plus 9 squared plus 16 equals 0. Yeah, we have here in example 4, it's doing both simultaneously. P plus 10 is squared equal to 100. It's a classical quadratic equation. What is the clue que give me information que es quadratic? Exponent 2. Any equation que contain exponent 2 is quadratic, right? Si contain another exponent greater than 2, entonces no, es quadratic, cubic, or 4 power. Pero we study quadratic. O sea, the maximum exponent so far is 2. Okay, entonces, what should I do? When I take advantage, que somebody do the factorization of this. Cool, I like that. And you isolate x plus 9 squared equal minus 16. Now ready to apply square root. One more time happen. Okay, square power and square root cancel out each other. And we have here plus or minus. Don't forget this, please. And this is 4i. Yes or no? Now the solution is I move 9 to the other side, minus 9 plus or minus 4i. Again, we have two solutions. By the way, always happen in the quadratic equation when the solution is complex. The complex is coming by pair of conjugate. Suppose you write solution set. Okay. Es negative 9 plus 4i, comma, negative 9 minus 4i. Two solutions. And they are conjugate each other. Because the imaginary part is positive, the imaginary part is negative. I don't care. The same real part. In this example, no. In this example, no complex, I suppose. You isolate 200 and you directly apply square root. So this method, guys, is square root. It's a p plus 10. And this is, 200 is 100 times 2. And square root 100 is 10. And square root 2 leave like that. So these two stay inside the radical. And 100 no. 100 go outside the radical like a 10. And don't forget, please, plus and minus. Que es the thing que every student forget. When you apply plus square root method, plus and minus. Finally, P. Who is P? P is minus 10, plus and minus 10 radical 2. We have real part, imaginary part. No, this is a real number. I don't see any I. We have two solutions. Solution set is minus 10 plus 10 radical 2 real, minus 10 radical 2 real. But both are weird. I understand that weird. It's this irrational solution. It's not. It's a complex solution. Okay, cool. It's easy, no? Pero, you know, not always a happy. Can be a 0. I have another more complicated scenario. So far, yeah, so far. In which, for example, you have this equation. In this equation, I can see que A is 1, B is 4, and C is 10. Okay, because I want to explain first of all, solving this quadratic equation, one project technique procedure que is called by completing the square. By completed the square method. And normally the student don't like this way. However, unfortunately, in the test on paper, at least one question, a specification que I need que you solving by this method. Suppose que you solving by another method que is good. You answer is good, but we have no credit because a specification que in this I need complete square. Okay. Don't worry, be happy. What should I do? Where's the organization? I want to explain without coefficients, with coefficients. This is easy because the coefficient A is 1. When the coefficient A is not 1, it's a little bit more complicated, but don't worry. I want to explain any scenario. You copy, bring down x squared, 4x. And I move this 10 to the other side. Always. The C, you move it to the right hand side. And you create here one magic number that completed the square. What means completed the square? Completed square means that you introduce artificially one number, in this case F4, I explain after the formula where come from this form. Because the factorization, so when you introduce artificially that 4, of course 4 on both sides in order to doesn't affect my equation, this trinomial here is perfect square trinomial. What means perfect square trinomial? Que the factorization is 2 factor, que is twin brother. Look, 2 plus plus. Okay, because 2 times 2 is 4 and 2 plus 2 is 4. Therefore, not necessary to write like that. No, I don't like this. I write like that. Because they are twin brother. And in the right hand side, we have minus 6. Do you see the idea? Let me finish. I explain what is the formula to find the magic number. You apply now. You finish always in the square root method. X plus 2 without square And it's a plus and minus. Unfortunately, 6 is no possible simplification, entonces leave it like that. It's I radical 6. Now x is equal minus 2 plus or minus I radical 6. This is the answer. You want to write, guys, I am a teacher, so I write in different way. However, to emphasize the idea, however, if you live like that, you are perfect. You are the best in Miami-Dade College. However, I don't know why I want to emphasize that actually is two solutions. Okay? Now the question is, bueno, professor, where come from this 4? Now this 4 come from you taking B, get 4 in our example, B divided by 2, always divided by 2 and a square. It's a formula to find the magic number that complete the square. It's doing, and it's a specific scenario. B4 divided by 2 is square. 4 divided by 2 is 2, and 2 squared 4. That is a reason that this 4 is this 4. And of course, in order to doesn't affect, you put the extra 4 here because I need to keep the equilibrium of the equation. Clear? Clear?
Yes.
Yes.
Okay.
Yes.
This was example 1. Okay, pay attention. Okay, I want to complicate this a lot of. Example 2, no, it's no big deal. Suppose this, x squared plus 6x plus 18 equal to 0. And the question says, solving this quadratic equation, but mandatory if you want to receive full credit by completing the square. You have to complete the square. What is the organization? The organization is you bring down x squared plus 6x plus something I don't know. Always a plus, no minus, always a plus. Equal minus 18 plus the same box. And so what is the magic number?
9.
9, very well. She said 9. Where come from this 9? 6 divided by 2 is square. 6 divided by 2 is 3. Square. I'm crazy. 6 divided by 2 is 3. And 3 squared, 9. So the magic number is 9. And when this, I put artificially this 9 and open the door for the solution, because this trinomial always is perfect square. And the factorization is only one factor, not 2, only 1. Well, actually it's 2, but it's twin brother, no? So it's x plus 3. Where come from this 3? Square root 9. And this sign is plus because this sign is plus. Si this sign is negative, entonces es negative. Equal negative 9, no? So far it's okay? 18 and 9 together, and negative 9. Now I finish my problem, apply square root both sides. So I take advantage, okay, factorization. This is x plus 3 alone, and this is plus and minus, don't forget plus and minus 3. Now finally, x is equal to minus 3 plus and minus 3. End the story. I finish. You are. Everyone follow me, or you are tired? Are you tired? Well,
I'm following.
okay, good. Let's doing one more complicated example. But don't worry for complicated. I suppose everyone have calculator. Entonces, to manipulate the number is no big deal. We are doing with the calculator, okay? Let's doing example 3. What is the new thing I bring this example? Well, the new thing is que A is not 1. So A is 6, B is -1, and C is -2. Y the teacher wants que I solving by complete square. Okay, I respect the teacher. I try to do my best. So now, as always happen, these two go in the other side. So 6x squared minus x equal 2. But I need to do something. I need to factor out this 6 artificially outside. Minus 1/6 x plus box equal 2 plus box. Okay, let me try to explain it. This situation doesn't happen when the A is 1. But when the A is not 1, you factor out this 6, because A outside. And here we have actually in the real equation -1. But when you factor out 6, 1/6, you divide. Because you are doing backward, you multiply 6 times x squared is 6x squared, and you multiply 6 times 1/6 is 1. Do you see it is or no? It's the only new idea. Well, no, we have another new idea. Do you follow me or no? I need to feel, can you follow me? Yes or no?
I'm not 100% following.
No, I know 100%. Okay. Okay. Let me try to do my best. Okay. In this case, A is no 1. A is no 1. I need to do extra thing. And the extra thing is factor out, pero factor out artificially, because in between 6 and 1, we have no common factor. So I factor out 6. Of course, if these 6 go out, here we have nothing, no, 1. Professor, I have no leave early. Okay. Now here is 1, but you factor out 6 outside, stay inside minus 1/6x. So far, I don't finish. Let's see. See, this is my audio stopped working. My audio stopped working. Oh, now let me see. No, my audio is okay. Everyone hear me or no?
Yeah,
I can hear you.
So what's the problem?
I can hear you.
Okay. Guys, don't interrupt me in the complicated part. Okay. When the A is no 1, is 6 or 20, or another example you have here 14, you factor out 6. You create artificially 1 new parenthesis, but in the part is only 1, x is 1/6. I want to prove that this and this are equivalent expression. Look, if you multiply 6 times x squared is 6x squared. Minus 6 times this is 6/6x. 6 times 1/6 is -1. Exactly like that. Did you see or no?
Yes.
Now, the complicated part. This is the magic number I need to find, equal to plus another magic number I need to find. I don't know. In this case, not necessarily it's the same. Why not? Because you have common factor outside. So remember, the formula is the same. The formula is b/2 squared. But who is b? Well, b in our example now is 1/6. Remember, I don't care the sign. The sign is not important. It's totally irrelevant. Entonces, when you divide it by 2, it's 1 over 12, correct?
Yes.
Because 12. Because it's b over b 1 over 6, sorry, let me concentrate in this. 1 over 6 divided by 2 is 1 over 6 times, flip it out, 1/2 is 1 over 12. Okay, and now you square. And when you square 1 over 12, this is b over 2. When you square is 1 over 144, right? Entonces es 1 over 144. This is the magic number. Do you follow me?
Yes.
Yeah.
Now. In the right hand side, you put 1 over 144. No. Why no? Because this 144, 1 over 144 is inside the parentheses. Basically, see, I want to keep the equilibrium. It's 6 times 144. And I multiply 6 times this. And this is 1 over 24. 1 over 24. Clear?
Yes.
Let me recap, because it looks like complicated. In order to find the magic number that you introduce artificially inside the trinomial, in order to convert like a perfect square trinomial, you take b, is 1 over 6, divided by 2 is 1 over 12, and you square this guy is 1 over 144, and you put it here in the story. However, in the right-hand side, you put the equivalent numerical value that you introduce artificially in my equation. Actually, no, this is multiplied by 6. Sorry, my Wi-Fi keep dropping my eye. Okay, guys. Okay. Do you want that I connecting with the AT&T? My daughter working AT&T. The student can need Wi-Fi fast and cheaper. Let me know if I connected with my daughter, okay? Now, we're going from 124. Wait. This is the multiplication 6 times 6, this 6 times 1 over 144. Okay, 6 over 144. When you reduce in lowest term, divided by 6, 1, and 144 divided by 6 is 24. Let me check it with my calculator one more time. 144 divided by 6, boom, 24. Okay, so this is the manipulation que I'm doing in my equation. The rest is piece of cake. The rest is piece of cake. This is 6. This is perfect square trinomial. It's x minus 1 over 12. Where come from this? X is the square root of this. And 1 over 12 is the square root of this. And we put together, put it in the calculator maybe, it's 49 over 24. Yeah, because it is, if you do it by hand, for example, this is 24, least common denominator, this is 48, no? Plus 1, and 49. Okay. Now, after that, why not? You divide it by 6, both sides. You divide by 6, both sides. The class is over. The class already is over, no? Let me finish this example and that's it, no? It's x minus 1 over 12 is equal 49 divided by 144. Okay, again, it's the multiplication. Square root both sides. X minus 1 over 12 is equal plus or minus 7 over 12. Okay, ready. X is equal, moving this 1 over 12 plus or minus 7 over 12. Two solutions. 1 over 12 plus 7 over 12. 1 over 12 minus 7 over 12. This is 8 over 12. Can you reduce the lowest term? 2/3. Boom. And here is minus 6, because 1 minus 7 is minus 6 over 2, I get negative 1. This is actually the solution of this. Guys, tomorrow, no, Wednesday, we continue doing the one problem of this and one more, another way, gets more efficiency. For me, it's important that today or tomorrow you enroll as soon as possible in Alex. Okay? Using, remember, you buy the code or no, you're using the financial aid. The financial aid code is too long. My recommendation is you copy and paste, because maybe if you type in by hand, you make a mistake. That is the reason they are doing this for. They are, you know, they want to sell code. So now, so you take advantage 2 weeks at least to start and roll, be familiar. You take advantage. Okay. So guys, was a pleasure working with you today. Excellent class, beautiful class. Okay, I suppose we are doing good semester. Okay, so bye-bye. Have a nice, good day. Good afternoon, because it's afternoon.
Bye.
Remember,
Bye.
soon I will send the video. Okay?
Okay, bye. Thank you, Professor.